welcome Yella to this virtual industry tour presented by myself, Naledi Chantunya. Today we'll be delving into the South African aerospace sector, a dream job for many young engineers, scientists, and technical professionals. I'm presenting this tour as a part of a program stewarded by the Stellenbosch Engineering Faculty, which is the birthplace of the Sunsat and a hub for aerospace and engineering at large. We will explore the four major axes in this industry, but expansion in these jobs is far from over. The future is in the hands of the next generation, so let's get into it. This is a short roadmap of the topics we'll be covering in this video. We'll begin with the definition, the government sector, satellites, UAVs and commercial flight, rockets and R&D, and finish with a expert consultation and then a closing. What is aerospace? An overview. Aerospace is the field of engineering and applied science concerned with the design, development, testing, operation, and maintenance of vehicles that operate within and beyond Earth's atmosphere. This includes conventional aircraft, helicopters, unmanned aerial vehicles, missiles, satellites, and launch vehicles. Globally, the aerospace industry is one of the most technologically advanced and economically significant sectors. As of the mid-2020s, the global aerospace and defense market is valued at over $800 billion annually, spanning commercial aviation, defense, space exploration, satellite services, and advanced research and development. Aerospace engineers and scientists operate at the intersection of mechanical engineering, electrical engineering, computer science, material science, physics, and systems engineering. Their work contributes not only to transportation and national security, but also to weather forecasting, communications, navigation, environmental monitoring, disaster response, and scientific discovery. In South Africa, aerospace is often perceived as a niche industry. However, this perception understates both its historical depth and its current strategic importance. Today, it is estimated that between 15,000 and 20,000 people are employed directly in aerospace and related supply chains in South Africa. However, many more are supported indirectly through manufacturing, logistics, data services, and infrastructure. This tour explores how aerospace functions within South Africa across the government, private industry, universities, and research institutions, and how it continues to evolve. Section 1. Government Aerospace in South Africa. Overview. The South African government operates one of the largest and most diverse state-owned aviation fleets on the African continent, primarily through the South African Air Force and associated defense entities. These fleets include fixed-wing aircraft, rotary-wing aircraft, transport platforms, surveillance aircraft, and unmanned aerial systems. A number of these platforms were historically designed, manufactured, or significantly modified locally, reflecting South Africa's long-standing aerospace capabilities. Examples include the Atlas or Oryx helicopter, a locally developed derivative of the Puma, and the Rooivalk attack helicopter, which remains one of the most sophisticated combat helicopters designed outside any of the major aerospace powers. In addition to crewed aircraft, South Africa has maintained significant expertise in missile systems, guided munitions, and unmanned platforms, where precision manufacturing, storage, testing, and maintenance are critical. At the space level, the government plays a coordinating role through the South African National Space Agency, or SANSA. Established in 2010, SANSA consolidated several earlier space science and satellite activities under a single national framework. Its mandate includes Earth observation, space weather monitoring, satellite operations, data analysis, and the development of national space infrastructure. SANSA also works closely with universities, particularly Stellenbosch University's Faculty of Engineering, which played a foundational role in South Africa's space satellite program. Government aerospace careers. Within government aerospace careers. Within the government aerospace ecosystem, engineers tend to work on long life systems, strict certification environments, and highly reliable platforms. Some key roles include a structural and materials engineer. These engineers design, analyze, and test aircraft structures, space frames, and advanced materials. Their work ensures that vehicles can withstand aerodynamic loads, fatigue, vibration, temperature extremes, and operational wear. Remote sensing and ground systems engineer. These engineers work on the infrastructure that allows satellites to communicate with Earth. This includes ground stations, antennas, data pipelines, calibration systems, and processing algorithms that turn raw satellite signals into usable information. Aeronautical engineering graduate. Graduate engineers in government programs often rotate through design offices, simulation teams, testing facilities, and unmanned aircraft projects, gaining exposure to full aerospace system life cycles. Engineering highlights. Wind tunnel testing. Several South African universities operate state-of-the-art wind tunnels, including low-speed, high-speed, and supersonic facilities. These tunnels are used to study aerodynamic flow, lift, drag, stability, and heat transfer on aircraft and spacecraft models, a critical step in validating designs before flight. Prominent company, Denel Dynamics. Denel Dynamics is South Africa's primary state-owned defense aerospace company. It is responsible for the development and production of missiles, precision-guided munitions, and unmanned aerial vehicles. One of its most notable products is the Seeker UAV series, long-endurance, unmanned aircraft used for border control, maritime surveillance, and reconnaissance. These platforms are among the most widely exported African-designed UAVs and demonstrate South Africa's ability to compete in specialized aerospace niches. Section 2. Satellites. History, public, and private operations. Overview. South Africa's satellite story does not begin in a government lab, but in a university workshop. The country's first satellite, SunSat, was designed and built by postgraduate students at Stellenbosch University. It was launched on the 23rd of February, 1999, from Vandenberg Air Force Base in California aboard a Delta II rocket. SunSat was a microsatellite weighing approximately 64 kgs and carried imaging, communications, and scientific payloads. At the time, it placed South Africa among a small group of nations with an indigenous satellite design capability. Following clip from the 1999 Delta II launches comes from Internet Archive and I think is a great watch.
6, 5, 4, 3, 2, 1. Have ignition and liftoff of NASA's Advanced Composition Explorer, looking to study the solar wind and further our understanding of the universe.
Symmetrically. Good ramp up. Guidance is controlling very well. Attitude disturbances at liftoff damped out nicely.
T plus 35 seconds.
Passing through Mach 1. Guidance system continues to burn very well.
T plus 40 seconds.
Ground solids are beginning their slow decline. Still got a good symmetric burn with all the solids.
Since then, satellite technology has undergone dramatic miniaturization. Modern micro, nano, and pico satellites, particularly from CubeSat, can perform tasks once reserved for much larger spacecraft. Payloads today include multispectral imagers, synthetic aperture radar components, communications, transponders, GPS, instruments, and scientific sensors. South Africa now hosts about 20 to 30 private companies involved in small satellite development, components, payloads, or data services. Satellite engineering roles. Electrical power systems engineer. Designs solar panels, batteries, and power regulation systems to ensure continuous operation during orbital day and ellipse cycles. Attitude determination and control systems engineer. Develops sensors, actuators, control algorithms, and others that allow satellites to determine orientation and accurately point antennas or cameras. Structures and mechanisms engineer. Designs the satellite's physical frame and deployment mechanisms to survive launch loads and operate reliably during orbit. An engineering highlight. Space hardening. Space hardening involves chemical and material treatments that allow components to survive radiation, atomic oxygen, vacuum, and extreme temperature cycling. Techniques include radiation-resistant doping, protective coatings, and polymer cross-linking, improving long-term electrical stability and durability. Prominent companies. New Space Systems specializes in spacecraft components such as reaction wheels, sun sensors, magnetometers, and GPS units. Their hardware flies on missions across 6 of the world's continents. SCS Aerospace Group provides end-to-end satellite systems, ground segment services, and training through its Space Engineering Academy. Dragonfly Aerospace designs and manufactures high-performance Earth observation satellites and imaging payloads. Its Stellenbosch facility can produce up to 48 satellites per year, supporting large satellite constellations. The following clip comes from Samirasense's clean room lab, which they keep immaculate and free of dirt to ensure that the payloads, optical imagers, work sufficiently. Section 3. UAVs and Private Aviation. Overview. The private aerospace sector in South Africa includes unmanned aerial vehicles, light aircraft, helicopters, and maintenance organizations. As manufacturing costs have fallen, the UAV industry has expanded rapidly. Drones are now widely used in precision agriculture, mining surveys, infrastructure inspection, conservation, and private security. UAV engineering roles: prototyping and flight test engineer. They lead rapid hardware iterations, flight testing, instrumentation, and failure analyses. Payload and sensor integration. They integrate electro-optical, infrared, LiDAR, or radar payloads while managing mechanical, electrical, and software interfaces. Power systems engineer. They optimize batteries, power distribution, and endurance for mission requirements. Universities, such as Stellenbosch University, also support UAV programs, while pilot training and licensing are regulated by the South African Civil Aviation Authority, or SACAA. Commercial manned aviation. South Africa's commercial aviation sector supports tens of thousands of jobs. On a typical day, over 2,000 commercial flights operate nationally, with the major hubs being OR Tambo in Johannesburg, Cape Town International, King Shaka, and Lanseria. Although most aircraft are manufactured by Airbus and Boeing, South Africa maintains strong maintenance, repair, and overhaul capabilities. Aviation roles: plane hydraulics engineer. They design and maintain high pressure systems which control plane landing gear, brakes, and flight controls. Turboprop mechanic. They maintain turboprop engines, focusing on combustion performance, gearboxes, and vibration analysis. Airworthiness analyst. They use data and analytics and AI tools to track maintenance records, detect anomalies, predict failures, and ensure regulatory compliance. Engineering highlights. Based in Johannesburg, the airplane factory designs and manufactures the sling range of light aircraft, exported globally as ready-to-fly platforms. Section 4: Propulsion, Research and Development, Universities, and the Use of AI. South Africa's rocket engineering ecosystem is led by universities, particularly the Aerospace Systems Research Institute at the University of KwaZulu-Natal. Founded in 2009, ASRI has developed hybrid and liquid rocket engines, including the Able engine, producing approximately 18,000 newtons of thrust. ASRI is also developing the Commercial Launch Vehicle, a two-stage rocket designed to place 200 kgs into Sun synchronous orbit. In 2024, South Africa inaugurated its first permanent sounding rocket launch facility at the Denel Overberg test range, followed by a successful launch of the Phoenix hybrid rocket. AI plays a growing role in combustion modeling, test data analysis, trajectory optimization, and manufacturing quality control, reducing cost and accelerating iteration. Rocket engineering roles. Rocket propulsion engineer designs engines and uses AI-based surrogate models to reduce the cost of running simulations. Dynamics and GNC engineer. They develop guidance and control algorithms to help the rocket achieve a stable ascent. Structures and materials engineer. They use generative design to create composites which reduce mass and increase strength of rocket bodies. What I learned from this tour. I learned many things during the research of this tour, but my favorite of which were the one, the R5B rocket program, which began pre-democracy. It operated experiments between 1980 and had its peak in 1992. They developed solid fuel rockets, and here is a picture of one of those launches. The second was I learned about the significance of the South African Air Force between the South African border wars with what is now Namibia and the involvement of the South African Air Force during the Rhodesian Bush Wars. From speaking with Professor Herman Stein from Stellenbosch University, I also gained insight into both the constraints and the global relevance of South African aerospace expertise. The following is a clip from the consultation I had with Professor Stein, and he had some comments on some questions that I asked. Here it goes.
Number 1. Which engineering skills do graduates constantly underestimate when entering satellite or the aerospace sector?
I think because there is no aerospace engineering really in South Africa at any university, and if you want to enter this specific aerospace industry, you need to know something about space engineering. But there's a lot of information on the internet, and you can read up on that yourself. And but if you don't do that and you try to enter the aerospace industry, you will find quite a learning curve initially that you need to overcome. It's not impossible. I mean, there's many engineers that's working in the space industry in South Africa, especially in the Western Cape. That's where most of the companies are located. Yeah, but if you really have interest in aerospace engineering, then I would say you need to read up a bit before applying for a job, for instance. The basic engineering skills are the same as in other industries, but there is some unique skills that you need to have as well, and knowledge that you need to have as well.
Okay. Oh, thank you for that answer. Question number 2. What unique challenges do South African built satellites face compared to satellites developed outside of South Africa, for example, in the US or Europe? When I say challenges, I mean perhaps with manufacturing, with demand, with research, something like that.
Yeah, so I would say we're far away from where space really happens in the rest of the world, and that's mainly in the Northern Hemisphere. So there's not a lot of supporting industries for your specific space company that do the mechanical manufacturing, find components,
Mm,
uh, also the environmental testing, because you need specific um, systems available to do environmental testing, vacuum, thermal vacuum, vibration testing, shock testing, and but at the moment, most of those components and systems are already in place. At Hotech, where the previous space activity was, there is some of these facilities available that one can use, anechoic chambers for satellites, for example, big vacuum and thermal vacuum chambers, although they no longer operational. Some of them, the smaller ones, have already been recommissioned, and they are used by space companies in the Western Cape. But for instance, in the company Keep Space, where I am at the moment, we have
mm,
our own thermal vacuum chamber in the launch lab, close to the university engineering building. We
I
have a,
see.
we have a vibration table there. We have a shock uh, instrument as well now to do shock testing. So you need to have these components available. Overseas, there's many facilities that you can just make an appointment and you can go and use it, and you
Yeah.
pay a nominal fee to use it. ESA in Europe has some offices distributed all through Europe and also in the UK. And in the US, you have NASA. NASA also
Mm.
has facilities all over America. But that is sort
All
of
right, sure.
lacking.
So,
Also, if you want to buy components, some of these components are manufactured locally in Europe or in America,
mm,
radiation hardened components for space use. And to get hold of these components are sometimes not easy. They're difficult to get hold of, they're very expensive. So you will find that most companies in South Africa that build components for satellites or build satellites will use commercial off-the-shelf components that's more easily
yeah,
available. They're not they're not space hardened. They're not, but that's why our components are much lower cost to what you have to pay for similar
exactly.
components in Europe and in the US. And you don't need, most of the time, you don't need these high reliable components for most, say, university space projects or new space project. It's called new space nowadays, where you have smaller satellites uh,
Mm.
that's launched in orbit around Earth.
All right, sure. So you find that most things have to either be built in-house, and if they can't, we'll just buy them off the shelf. And even
Yeah,
testing would be in-house. Yeah.
yeah. You
Okay.
need, if you build components for space use, you need to do environmental testing. Otherwise, no one will be interested in buying them.
I
Uh,
understand. Mm. All right. Well, thank you so much for that. Question 3. What excites you most about the next 10 or 15 years in the aerospace industry within South Africa? Where
yeah,
do
I
you see
think
that going?
Yeah, I think we're quite competitive. Not so much in building full satellites, because that is more difficult to get into uh, in the world because of the various um, big space countries in the world. They all have their own space industry, and normally when they get funding to do a space project, build a satellite, for instance, that funding comes along with provisions that you need to buy locally. You cannot go and buy your components from South Africa, for example. But we found in the company CubeSpace, where I'm part of, that we can still supply components to European and American companies and Indian companies even, and companies in Japan doing satellites because of our competitive prices. So we can sell components, similar components to what you can get overseas for a fraction of the price, 20% or 10% of the price, because our costs, manufacturing costs, are much less.
I see. That's perfect.
Yeah.
Thank you.
Sources of information and use of AI. My sources included academic publications, company websites, archival footage, interviews, and publicly available databases. I used AI tools such as ChatGPT and Grok to assist with my research, fact-check me, and formalize my writing, while ensuring that all ultimate interpretations were my own. Much of the facts and history were available on Wikipedia. Also, a lot of the images are sourced from Wikipedia. I used ChatGPT and Grok AI to scrape the web for less structured information and for fact-checking and formalizing. Websites like Internet Archive were used to find original launch footage and notes on the Delta II rockets. I was graciously gifted slides from Prof. Stein from a presentation he made in the past. It presented me with first-hand details, insights, and original images. Otherwise, I used company websites and YouTube videos to educate or summarize information that I did not know. To conclude, the South African aerospace industry is one on its precipice. Existing infrastructure and investment allow for a blossoming aviation sector, but satellite programs are slowly catching up in private adoption and innovation. Much of the research and development in the technology is spearheaded by universities, and the students that leave these institutions go on to build, create, and collaborate on an international level. The variety of skills, especially aided by cheaper manufacturing and implementation of AI, mean that the barrier to entry in this field have been tremendously lowered. The triumphs in aerospace in South Africa in the late 20th century have laid a foundation of curiosity and experience which are being built on top of using modern tools. It's been a pleasure to uncover the wealth of knowledge and creativity during this tour, and I hope it has inspired you and deepened your understanding. Thank you very much. Ke a leboga, and goodbye.